So this is a talk from Andreea Roche. She works at Jaguar Land Rover, and this is titled The Joys and Perils of Real-Time Vehicle Data. And if anyone's ever tried to buy a car since 2020 or tried to work on one since 2020, I've done a fair bit of work on one myself, you'd know that having a lot of service data about whether or not your car's about to fall to bits would be fantastic, because I have spent the last month under my car every weekend doing the job of what sensor data could have done for me. So if I had a more modern car, which I'm punishing myself really by having an older car, I would have known that everything needed servicing on it. But enough about me. Please welcome to stage Andreea Roche.
All right. Hi, everyone. Hopefully you can hear me. I've called this talk The Joys and Perils of Real-Time Vehicle Data because I couldn't come up with anything better. Because today I want to talk to you about what happens when you try to capture accurate data about hundreds of thousands of customer vehicles out there in the world, and you use this data to carry out millions of wireless updates to these vehicles to enable you to both fix existing issues on software in those vehicles and roll out fantastic new features for all of your customers. And what tends to happen is that you run into lots of risks or perils, especially when you're trying to scale up this process that is already very complicated, to be able to do even more updates, and particularly to be able to do more complicated, customizable updates to even more vehicles. But the payoff to that, the joy in this, is that you get to deliver great value to your customers, but on a more personal note, as a developer, you get to learn loads and loads about building systems at scale and managing really large volumes of data. So today I'm going to give you some of the highlights of our learning process. And I'll try to give a little bit of time at the end for questions, but there's lots of things I want to share with you, so we might run out of time. But please come up to me afterwards and ask me any questions you have, because I love talking about this. So here we go. First, let me introduce myself a little bit. I'm Andreea. I'm a senior software engineer at Jaguar Land Rover. I've been working here for about 2 years now. And as I've hinted, today I'm going to talk to you about a project I worked on that centered around processing real-time vehicle data. We started building this project in August of last year. We released the first set of features for this in January of this year, and we have been fully running in production since March, and we now process around 1 million files from customer vehicles every single day. To also give you a bit of context as to why I'm talking to you about this, and what my journey has been with learning about MongoDB. When we started this project, both myself and the 2 other engineers that I worked on this, we had some experience of working with MongoDB. We already used MongoDB databases in other services in our team, but we'd never really built something like this from scratch. We'd never had to think about how to create a system that needs to deal with this much data volume coming in all the time. And we never had to create something where MongoDB was really central to everything we wanted to do. So this is a bit of a presentation about what we learned from that process. To also give you a bit of an introduction into who Jaguar Land Rover is, in case there's anyone in the audience who's not familiar. Jaguar Land Rover is actually 2 distinct British brands, Jaguar and Land Rover, and we build beautifully designed, incredible vehicles, which tend to win lots and lots of awards. We're extremely proud of our products. For example, our new Range Rover has already won a few awards this year. And Jaguar Land Rover is going through a big process of transformation right now. We had a great presentation this morning on sustainability. Sustainability is definitely at the top of our minds. We have set ourselves the impressive goal of being able to produce all our nameplates in pure electric form by the end of the decade. And we're also aiming to achieve net zero carbon emissions across our whole supply chain products and operations by 2039. So in order to get there, there's a big process of transformation happening within the company and a lot more emphasis on technology. And this incredible technology of sending software updates wirelessly is a big part of that. So as a bit of a roadmap for today, I'll first talk you through a few key concepts and systems. I'll try to explain some of the acronyms I'm going to use in this. I've tried really hard to keep that to a minimum. I'll then give you a bit of an insight on the problems we had with the current system and why it wasn't very scalable. I'll then talk to you about why we decided to use MongoDB for our solution, give you an overview of what that solution actually is, what is it that we actually end up implementing. And finally, probably the best section of all, I'll talk to you about a couple of the major challenges and lessons learned we learned from building all of this. So, key concepts and systems. Software over the air, or SOTA, is Jaguar Land Rover's way of delivering software updates wirelessly to customer cars. I sort of explain this to people as being similar to what would happen to your phone. If there's an update to something on your phone, you'll just get a notification and then you're able to just download and carry out the update. This is what we're aiming for with SOTA, really, to have this kind of seamless process of sending updates out without customers needing to go into a retailer, any kind of physical action to happen on a customer's car. Now, updates range from patches where we just fix existing problems on the software to the more exciting type of updates where we get to actually roll out new features across our fleet. So 2 examples of this that happened this year. We rolled out Alexa to the infotainment system in February, and we rolled out What 3 Words on the onboard navigation system in June. SOTA, as I know it, as the team that work on it know it, has been running in production since August 2020. In that time, we've been able to make 3 million updates to individual vehicles. But there's about 440,000 vehicles that can receive SOTA updates. And in fact, since I wrote the slides for this is inching closer to 450,000. As more vehicles are made and sold to customers, this keeps going up and up. So there's a lot of, if you look at the difference between the 3 million updates and all the vehicles we have that can receive these updates, there's lots of potential to do more updates to more vehicles. But the process of updating such a huge fleet of vehicles is not really straightforward in any way because there's a lot of variety between what is on vehicles in different parts of the fleet. So although something like Alexa getting updated into your infotainment system will look the same to customers using different vehicles in different countries, different models, what actually happens in the back end to make that possible is that we can't send out only one software package to roll out something like Alexa. It's actually many different software packages for different vehicles. So our way of managing the complexity of doing these updates across a whole fleet is the concept of a campaign. So a feature like Alexa is sliced up into different campaigns in order to be able to manage updates to different parts of the fleet, but also to be able to roll out updates. Because with something like Alexa, we don't want to do like a big bang release where we roll it out to every car that we have everywhere in the world. We want to be able to do it in a more staged way. So campaigns really are just a way of managing SOTA updates. A campaign will have a software target. That's the software package or packages that is physically sent out to a vehicle, and it will have a set of targeted vehicles, and these are the vehicles that have been nominated to be to receive this update. The team of software engineers that I work on don't create these campaigns. They're created by a number of vehicle data engineers who are very skilled at what they do. They have a lot of knowledge and a lot of data that feeds into what kind of campaigns they create, what vehicles they nominate for which updates. But the team I work on makes it possible for them to do this in an efficient and safe way. And then the other important concept to understand is vehicle targeting. And really, vehicle targeting is the validation process that we put SOTA campaigns through in order to make sure that the right updates are going out to the right vehicles. There's really two stages to vehicle targeting. First, we check, is this vehicle ready to receive a SOTA update? There's a number of rules that we have around this, where there's a number of states when the vehicle shouldn't receive any update. And then the second part of vehicle targeting is, can this specific vehicle receive this specific update? Because like I mentioned, there's a lot of complexity involved in rolling out an update, and different vehicles should receive different software packages for those. So to give you a bit more of a view of what all of that looks like, because I talked with very little text for a long time. So this is a current process for creating a campaign to be able to get software pushed out to a vehicle. So one of the vehicle data engineers will use one of the front-end applications that my team helps run. They will create a campaign. As part of that creation process, the vehicles they've nominated for that campaign, so the tagged vehicles, will go through a validation process, and we'll check data that we have on what is on that vehicle right now in order to determine whether that vehicle should receive that update or not. And the way the vehicle targeting or validation process works is vehicle data engineers basically input a set of dependencies into the UI. They'll say, if the vehicle has this and this and this and this, it's okay to go out and have this update. If it doesn't, don't do the update. It sounds pretty straightforward. The complexity comes from the volume of data and the different configurations that we have on different cars. And then if validation is all fine, those vehicles are okay to get this update, and then we go back into campaign service. Then we'll go to a service I've called just push update service, but it's an abstraction for a couple of different services doing quite complicated things. And then we'll go to Harmon, which is an external system that we use to actually send out the software package over the internet. And then once the vehicle begins downloading and installing the package, there's also a feedback loop of us constantly receiving feedback from the vehicle to make sure that the software update goes through successfully. So there's also that side of the process. All right, so as you can imagine, a very key part of this vehicle targeting process is just having really accurate, up-to-date data about what's going on in the vehicle. Because as I mentioned, the dependency rules for campaigns are expressed in terms of if the inventory is this and this and this, then that's okay. If the inventory is something different, don't let that vehicle get that update. Under the old process, architecture around vehicle data looked something like this. So we used a very, very large MySQL database called Digital Twin to store all of our vehicle data. And the way data gets into Digital Twin is that when a vehicle is built, when it rolls off the production line, it triggers an event which goes into something I've called manufacturing service. Again, it's actually a bunch of different services doing complicated jobs. But we then upload a full electronic bill of materials into Digital Twin. Because at this point, when the vehicle is made, we know exactly what is on the vehicle, both in terms of hardware parts and software parts. So at this point, our data about the vehicle is extremely accurate. What happens, however, is as the vehicle goes out onto the world, changes happen to the vehicle. So vehicle goes into a retailer, maybe there's some sort of problem in the vehicle, a part is maybe physically swapped out. We need to update the data. And we use a event-driven architecture sort of around these change events in order to be able to update the data in this MySQL database. So we have a data source in retailers where we get change events from retailers when they've changed something on a car, and we use those to update Digital Twin. We also have a different stream of events when a vehicle completes a SOTA update. Now that we're doing millions of them, we use that. We need to use that to update the state of the vehicle in the database as well. And this system works fine, and it particularly worked completely fine in the smaller scale that we had, but it has some serious drawbacks or perils as well. So we are reliant on manual action in retailers. A technician has to plug the car into a specific system for this change event to be generated. And of course, anything that is reliant on manual human action is liable to be flaky sometimes. The other problem with this was that we only get change events once. So if we have some kind of outage, I don't know, the RabbitMQ server we use for this goes down for, let's say, 40 seconds, or there's some sort of other horrible problem, we might miss out on a small or large number of change events, and we don't get that data back again until the vehicle has to go into a retailer and it gets plugged into this physical system. So we really wanted to have a way of capturing vehicle data more than once. We wanted to have a system that was self-healing, that would allow us to recover from outages. Not that we predict we'll have outages, but we wanted to be safe. And the last problem with this whole system was that it used a very inflexible schema in this MySQL database. So Digital Twin stores all the information about vehicle inventories in using an entity called an assembly. And an assembly looks something like this. It's really not very complicated. An assembly is a unique combination of hardware parts and software parts. We call software components installed on a hardware part, software parts as well. And each unique combination on a vehicle out there in the world has a different assembly in this database. And it doesn't look like a very big problem, but what actually happens is on particular ECUs, or electronic control units, there's a huge amount of variation in maybe the hardware parts or specific software component parts for good reason. But what that means is these ECUs have a huge amount of assemblies that all reflect a similar structure. So when we're doing a SOTA update, we almost always are only updating one or maybe two components on an ECU. But if we have to constantly translate our dependencies from parts into assemblies, this adds a huge amount of complexity to the work that vehicle data engineers have to do when they input dependencies in our UI. And this is a simple example with just two assemblies, but on certain ECUs, there's hundreds of assemblies. And in order to carry out a relatively simple update of just, they want to move the version up on just one component on just one ECU, vehicle data engineers would have to input hundreds and hundreds of different part numbers for these assemblies. So this really wasn't a very scalable process, particularly in terms of the humans involved in this process. However, Digital Twin is not just used for vehicle targeting. It's a huge database used by many other systems downstream. We couldn't feasibly make any changes to the schemas, and we shouldn't as just one of their users. So what we decided to do instead was, well, we sort of came up with a two-part solution of our two problems of wanting to have more resilience in our systems and also wanting to have a more flexible schema and a schema that reflected better what was actually on the vehicle. Because the vehicle itself just has software parts and hardware parts. It doesn't know anything about assemblies and it doesn't care. So the solution we came up with is to use a new data source for real-time vehicle data. So all the vehicles that are able to receive SOTA updates also have this amazing capability of sending reads of their inventory back to us over the internet. And again, a different team in Jaguar Land Rover deals with this whole process. They do a great job of capturing this data back, coming back from the vehicles, and they just store it for us in cloud storage like magic, and then we just subscribe to that and again use an event-driven architecture to get an event every time a new file is uploaded in. But the great thing about using the vehicle itself as a data source is that the vehicle generates these reads regularly as it's being driven around. So we're no longer reliant on making sure that we consume every single message we get from the vehicle. If there is some sort of horrible problem, if something needs to go down for 5 minutes, it's no longer the case that we need to wait possibly for months for that vehicle to go into a retailer with a problem. we can just wait for that vehicle to be driven again and consume that message again, and use that to update digital twin. So we're still committed to maintaining digital twin as accurate as possible. But what we also realized, partly because these inventory reads come to us in JSON format, is that we should just create a new database that we would explicitly build to use it for vehicle targeting, make it exactly the schema that we need, and keep it up to date using this inventory files. So why did we decide to use MongoDB to build this solution? Well, first of all, schema flexibility. We learned from the mistakes of our previous architecture. We learned that SOTA changes so quickly. We work in such an agile way. Whatever vehicle targeting is today probably is not what it will be 2 or 3 years from now. Probably will do more customizable, sort of person-specific updates. Maybe we'll have different data sources. Who knows? Having a flexible schema, which is one of the key benefits of MongoDB, means that we keep the door open to however our systems need to evolve over time. The other major plus for MongoDB for us was scalability and reliability. Because this is a system that needs to work 24/7, and we don't want our engineers to have to work 24/7, it was really important to go with something that has auto-scaling built in, that is reliable, and where we're not the only people responsible for keeping that system alive, because we're not deploying it on-premise. We use MongoDB Atlas on the cloud. And lastly, and on a more personal level, what was really important was developer experience. Like I mentioned at the start, I'm a software engineer. I'm not a data engineer. The idea of writing, SQL stored procedures is a little bit terrifying to me. The idea of having to roll out a schema change in SQL is also a little bit terrifying. But MongoDB allows us to do everything, well, pretty much everything through code. And it allows us to, we really try to foster a true DevOps culture at Jaguar Land Rover. So we want the engineers that work on the system, people like me, to be able to do and own every part of that process. So I can create a new database in MongoDB with pretty much no help from my SRE team right now, and I can roll out a database schema change just using Java code, which I do feel very comfortable writing. So it's really, really sped up our development process. What it has really also helped a lot with is testing. So we work with software engineers in test, and historically, when we were using the old MySQL database, it was very difficult for them to get test data in and out because it was such a complicated process to access data in this database. However, Mongo Atlas and Mongo Compass are so user-friendly. They're so easy to use. We find that it's really easy for regular software engineers and software engineers in test to put test data in and use it for automated and manual testing. All right, I've talked to you about how we came up with a solution. What does it actually look like? So briefly, what happens now when we get an inventory file is we have a set of 4 different MongoDB collections where we make updates to based on the contents of that inventory file. So first, we just check, is this a new file compared to what we have already in our collections? If it is a new file, then we perform a check where we check, do we need to update digital twin based on this file or not? Regardless of the outcome of that check, we send back a update report event, and we collect these in order to create meaningful metrics, which I'll talk to you about in a little bit. And then we also keep a couple of records of this data. So we have a collection where we just store the raw JSON files, which is great because it's so easy. With Mongo, we can just stick that JSON straight into our collection. But we also have a collection where we keep track of the as-is state of a vehicle, and one that is like a Delta collection where we keep track of what has made changes to the vehicle for lots of different reasons to do with compliance. So now to the good bit of this presentation. What were some of the challenges and major lessons learned from this? So it was hard to pick just 2. But the ones that I picked were production data can defy your expectations, and meaningful metrics are priceless. I'm sorry, both of these are a bit cheesy, but bear with me. So when I say production data can defy your expectations, what do I mean? So when we started the project, we knew the problems with the data from our stakeholders, but we didn't really have a clear understanding of what the data looked like across this massive amount of data that we had, because we have almost 500,000 vehicles. So we spent quite a long time at the start coming up with ways to structure our data. So, and we did know, we read about the principles of structuring data in MongoDB, so we did know that it's best to store data that is related, that you want to query together in a single document. But we were a little bit suspicious of this. We wanted to be skeptical. So what we tried first was structuring our data into 2 different collections. We basically tried to replicate assemblies. We removed the complexity of the end user having to deal with assemblies, but we kept assemblies in the back end. And we thought, there can't really be that many different variations. This will probably have better performance than just storing everything in one document. But what we realized, just doing manual testing on about 100,000 files, was that actually the problem was much worse than we thought. For some common ECUs, there's up to 900 different unique configurations of parts. And the performance of trying to do queries in these 2 separate collections was just awful. So we went back to the drawing board and decided to stick with, well, one of the core principles of data modeling in MongoDB, of just storing all related data together. So now we have this as-is collection has all the inventory stored into one document. And then the other major lesson we learned was that meaningful metrics are priceless. So I mentioned we have a series of events that we generate that are a report comparing the data in these inventory files and the data we have in MongoDB, well, not in MongoDB, in the digital twin database. So we wanted to start a conversation with our stakeholders about what this data meant to them and what accuracy meant and what they want out of this data. And so we started off really simple and just created a simple metric of comparing how many times is there a difference between what the vehicle inventory read says and what the MySQL database says. And really the great thing about this was just that it started a series of really good conversations with our stakeholders, with vehicle data engineers, with data engineers in other parts of the business, because this uncovered a number of issues they didn't know about, but it was simple enough that we could use this to talk to them about what really matters to them. And for this one, because it was the metric that we really start with, we now have a huge dashboard of lots and lots of different graphics and metrics. For this one, we just used Prometheus, but we've since began using the MongoDB plugin in Grafana, which is really great for creating really quick metrics. If any of you use Grafana and haven't used the plugin, I really recommend it. But yeah, and honestly, one of the best parts of this process has been that it's grown the relationship we have with stakeholders by using data and meaningful metrics like that. And I think that is most of what I have time for today. I should also mention, lastly, that we have a number of engineering roles open. We're going to be in the expo hall this afternoon, so please come and talk to us, ask us about what it's like to work at Jaguar Land Rover, and please also scan the QR code and provide feedback, because I'd love to hear what you think of this presentation.